All right, we've got some more line stuff again. The topics are jumping around a little bit. I didn't look through the textbook before I looked at this. I'm not sure how they're tying it together, but we're back to the idea of slope. So we saw some line stuff to begin chapter 2, and we're back at it. So do you remember the slope of the line can be thought of a couple different ways. It can be thought of the rise over the run. So in other words, the up and down and the right and left. But really what it is, and that's true, but it's another way of thinking of it, is the change in the y's over the change in the x. So the slope is, how is the line building? So how is it going up and over? It follows a pattern that keeps repeating because it's a line. And so the slope tells us the story of how it's going up and over. So we can find that if we have any 2 points, because it doesn't matter what 2 points on the line you choose. If you just see how you've changed the rise over the run, the change in the y's, or the change in the x's, you can find how to build the line. So again, this is probably a review for you. The only thing that you might struggle with here is just be sure that you don't mix up the points. So you've got, these are supposed to be x's. So I'm going to make this my second point. So I've got my y, my second y minus my first one, my second x minus my first one. I just tidy up the math, be careful of the double negatives there, and I get 4 over negative 7. Remember, you can write a fraction like that any way you want with the negative sign. You could even do it like this. The reason you could think that this might help you build the line if you thought of the negative on the front. But it doesn't matter. All of these are equivalent, and so we get negative 4/7. So let's try another one here. So y2 minus y1 over x2 minus x1. And this is going to tell us how this line is built. What is its slope? So I've got 4 minus 6, 1 minus negative 2. Just be careful of those double negatives. So I've got negative 2, so this will become a positive over 3. So you can write that negative anywhere you want to put it. I'm going to put them out front. And my slope for this line that passes through these points is negative 2 over 3. So if you were thinking of it as building it, you're going down 2 over 3. Down 2 over 3. Okay, now I don't actually use the point slope version of the formula very often, but it can be helpful. So suppose you wanted to build a line and you had the slope and you had a single point. You can use this equation right here. It's nothing fancy. All it is it's nothing to memorize. All they did was they took the slope formula and they moved this up here. So they just swung this, the x2 minus x1, they moved it up here. And so now I'm going to write it the other direction, but you would have this. Okay, now here's what they're saying. We don't know the other point. We only have a single point. So instead of calling this x2 and y2, we don't know that point, so we're going to leave it generic, and that's how they get this formula. So it's just derived just from the basic slope formula. Now, I'm going to show you a different method. You could use that formula. It'll get you there. But I think a way students find more success here is just using this formula, slope-intercept, that they're more comfortable with. And we're going to solve for b. So here's what I mean. The information they gave us is we've got some line. We know how it's built with a slope of negative 3. And we have a single point that it passes through. So what I'm going to do here is I'm going to plug in the slope. So I've got always goes in front of the x. Now the problem is I don't have the y-intercept. Well, let's use this point to solve for that b. So this point says y is 8. The x is 4. So solving for this, I get negative 12 plus b. So I'm just swinging the 12 to the other side. So plus 12, I would get 20. So plus 12, plus 12. Okay, so b is 20. Now you're not done. We knew most of the equation right there, but we now know the y-intercept. So y is negative 3x plus 20. Now if we had done we had done this, we would get to the same place. Now, I recommend students do this, but I'll just show you. I'm going to distribute that. Okay, so now I'm going to add the 8 to the other side. We get the same thing. So take your pick. If you're comfortable with this, you see where it's derived from, and it is faster, but this is what students feel most comfortable with because they're pretty comfortable with that slope-intercept form. Okay, so let's try it again. I'm going to do this way. Got my slope, and I don't know the y-intercept. Now let's plug in a point here. Plug it in my x and y. So b is -3. So you're not done. If you do it this method, you got to show me that final line, and we have this. Okay, so we're doing the same thing here. We've been given 2 points and we want the line. Well, what are we going to do? This is exactly the same problem as the last one. It just has the extra step. We need to find the slope. So we need the slope and a point. Well, we have 2, but we can easily find the slope just from our slope formula. Now, we have the slope, and we could use either one of these points. Well, actually, this point, if you notice here, that's actually the y-intercept. So I have my slope at 7/3 x. Well, I have the b. It's -3 because that's what that point would be. When x is 0, you have what the value of y, you have the y-intercept. That's what b is, and I've got my equation. All right, now they've done some of this in a little different order than I would. The standard form of a line, so we've been working with the slope-intercept form. Looks like this. And what's great about the slope-intercept form is this point here is the y-intercept, and you could then build the entire line with that y-intercept and then the slope. We actually haven't done it in this course yet. It's kind of out of order. Now, the beauty of the standard form is when everything is over on one side. And it's not nearly as helpful, but it is more valuable for finding the x and y intercepts. It's faster. So the standard form is all the x's and y's are on one side. You've just got a constant on the other. The slope-intercept form is much more valuable overall, but this has its uses too. Okay, so they want us to write this in the standard form. So this is the same type of problem we've already done. Y equals -6x plus b. And I have a point that it passes through. So I'm going to put that point in. Oops. Okay, put that point in. Now let's tidy this up. So negatives, I'm going to reduce this down. So I get -3/2 plus b. Now solving for b, so I'm adding 3/2 to both sides. Okay, so if you think about this, this is 1.5. So I've got -2 and I'm adding 1.5, so I'd have -1/2. So I'm not done. I'm going to put this back into my equation for b. Now this is the slope-intercept form, and they asked for standard form. All I got to do is get all my y's and x's on the same side. And I have this. Oh, you know what? It is true here. So my standard form, I don't know if this is necessary, but so I see what they did. So they got this so that this wasn't a fraction. And the way we would clear that fraction out is multiplying both sides by 2. So if I multiply both sides by 2, I'm going to do it to all of one side, I'm going to do it to all of the other. So I'd get 2y plus 12x equals -1. So they didn't like the 1/2 there. I don't know if it's required. I would still think it's standard form, but if you want that not to be a fraction, multiply both sides through by 2. Okay, we're going to do this again. Pause the video if you want to try it on your own. Here's what I've got so far. I'm going to plug in the point to solve for b. Okay, so I didn't show everything, but I'm just adding 1/3 to the other side. So now here's my b. So my slope-intercept version of the equation is this. Okay, so we're going to swing. Now, the standard form is what they asked for. So we want all the y's and x's on one side. Now, I guess this is required. I don't know. I've never thought of it before, but so I guess we want this to have no fraction and no denominator over here. So we're going to turn this into 2 by multiplying both sides by 3. So I distribute this 3y plus, you see how 3 and 1/3 is going to make 1. And over here these will cancel and I'll get a 2. And there I am in standard form. Okay, now they're talking vertical and horizontal lines. Again, you've seen this. But a horizontal line is where y, in this case, y is always -2. So I find -2 on my graph, and then y is always -2. So it's going to make a horizontal line. If I had x is -3, I'd find -3, and it's saying x is always -3. And so I'd get that vertical line. Okay. Oh, okay. I wonder what the point of this was. All right, so they've given us the equation. They've given us 2 points that we pass through. But notice something. So we could go through and start to go, okay, well, this is what I started to do. We need our slope. Then we've got to use either one of the points to find the equation. But if you look at this, an interesting thing happens here. The x's are the same number. So if the x's are always the same number, well, it must be a line where x is always 1. Now, the same idea here. You go, okay, well, let's find the slope. But then we notice, hey, the y's are always the same number. Well, if the y's are always the same number, then this is a line where y is always 2. Okay, I'm assuming we've got one more section that involves lines in 2.2c coming up. But so this was just a basic refresher over slopes and how to find the equation of a line in slope-intercept form. So start in slope-intercept form, and then you can convert it over to the standard form.